Okay guys, are you ready for more? So now let's move on to our next problem. So far so good. We've already done items number 1 to 4 or 5, and now we're already here at the next item. Are you ready? So now let's continue on with our next problem of hypothesis testing. You know what to do. Alright? So now let's do item number 6. Here we go. So Brother Jason Patrick Chua. Okay, so Brother Jason, shout out to you po. Because I know Brother Jason is also one of my brothers in my church. And I'm very excited to meet him tomorrow when I go to Christian Gospel Center. So Brother Jason, if you're watching this video, shout out to you po. Please pray for my studies. Sana mahusay ako sa pag-aaral. So yeah. So shout out to you po. Anyway, back to the problem. So sabi ko dito, si Brother Jason, he played the Chimps Coin Challenge found in Super Mario Galaxy. Yeah, of course, you know that game Super Mario Galaxy, right? Yeah! That's the game where I get to beat the chimp. But that's in the second edition. The one that you see me plays most of the time is in the first edition. Waha! Yup, that's the first edition, or that's the second edition. Because nowadays, we're now playing the first edition. Okay? Because I know normally, I will always play the second edition most of the time. But nowadays, since I'm so used to now the first edition, that's why I play it most of the time. Although I kind of miss already the second edition because, yeah. The second edition has much more gimmicks compared to the first one. And furthermore, there were lots of exciting, memorable memories that I had in that game. So, yeah, I just hope I could play that game again. Because I know that game brings me lots of wistful memories. I just hope I can get that Super Mario Galaxy game again. But too bad I can't play that right now because I'm still not yet done in the second edition. So, yeah. Anyway, let's go back to our problem. Sabi ko dito, he executed the challenge and got a high score of 11,800 points. You know that Slimy Spring Galaxy where you have to, you know, let the light defeat all the enemies there. And then you collect some points in order for you to win. So he scored 11,800 points, which was the general high score that anyone playing this game could get. However, when he asked 50 randomly selected gamers about this, the sample mean he obtained is 11,960 points, which is not exactly the normal average as it turned out to be. With a standard deviation of 800 points, he used 6% level of significance when it comes to computing for the test statistic, and he concluded that the null hypothesis was rejected. Is the conclusion true? If false, what error has he committed? Okay, so now you know already what to do. First, let's identify what is a given. First, what is the null hypothesis? The null hypothesis is 11,800 points. So just like what I put here, ito po yung sinabi ko sa stats and props ko. So our null hypothesis is that the mean is equivalent to 11,800 points. That is our H sub O. What is our H sub A? The alternative hypothesis. The mean is not equivalent to 11,800 points. Pero teka, bakit ganon? Why are we using a two-tailed test? Let's read the problem again. Sabi ko dito, he executed the challenge and got 11,800 points, which was the general high score that anyone could get. However, kapag tinanong niya ng 50 randomly selected gamers, the sample mean is 11,960, which is not exactly the normal average. So based on the grammar, which is not, hindi, which is not exactly the same score that he got. That is equivalent to none, not equal. So therefore, our H sub A, or which we call the alternative hypothesis, is not equivalent to 11,800 points. So that is our H sub A. Okay. Now, let's solve for the following. And then what is our level of significance that he wants to use for the test? His level of significance is 6%. Pero it's a two-tailed test. So therefore, it's 6% divided by 2. And what's 6% divided by 2? 3. Diba? So 3%. So we need to find 3%. But where is it in the graph? Ganito siya. Diba? Remember, that's equivalent to 50%. And then 3%, that's 47%. So, but later, I'll tell you that. Sige, let's solve for the critical area first. Because that's what we need to put in our rejection area. So remember, our critical value is 6%. Pero since we're doing a two-tailed test experiment, that's why we need to divide the 6% into 2. So therefore, it becomes 3%. Now, we need to find 3% in the graph from the tails. And that is 50% minus 3% to give us 47%. Now, looking at our Z table, where do you think is 47%? Yup, you got it. It's in between the two values of 0.4699 and 0.4706. It's right in between 1.88 and 1.89. 1.88 and 1.89. So yan. So now we apply the linear interpolation as follows. So now we get the closest and then we apply the linear interpolation method. Alright? So ang ginawa ko dito, sinattract ko yung mga numbers. So therefore that becomes 0.007. Diba? This one becomes 0.01. Then on the right hand side, we have 0.0001. Then on the bottom side, we have x minus 1.88. Now, ang kailangan namin gawin, i-cross multiply. So when I cross multiply these numbers, of course, 0.007 times x is equivalent to 0.007x. And then, and then this one times negative 1.88, I did it this way. Yan, and that's 1316. Pero, how many decimals is that? That's 6. So 6 decimal places, and that's 001316 point. So yan, di ba? And then all we have to do now is to just add, di ba? So kailangan tayo na mag-add ng 0.001316 on both sides, di ba? Before that, what's 0.01 times 0.001? Of course, you just copy the ones and then count the decimals. How many decimals are there? 1, 2, 3, 4, 5, 6. So 6 decimal places. It's just like multiplying with powers of 10s, di ba? So this one can be translated as 10 raised to the negative 2 power. This one is raised to 10 raised to the negative 4 power. And then remember, applying the laws of exponents, you have the same base. The base are identical. 10 raised to the negative 2 times 10 raised to the negative 4. Of course, you just, what do? You add the exponents, di ba? If you're multiplying with the same base and then your exponents are different, so therefore you just add. So negative 2 times negative plus negative 4 is negative 6. And 10 raised to the negative 6 is, tama, 6 decimal places to the left. So 0.00001, just like that. And then we add. So we get there is 0.001317. Then dividing both sides by the 0.007, ito yung ginawa ko. I'm sorry if I can't solve for the answer right away. But all I can say is when I divided this, we got 1.88. So let's see if this is true. Alright? Tama, we get our z-score of 1.881429. That is the z-score that we're looking for. So, tama. Now, as we type our critical value, di ba remember, this is what we did here, di ba? Yung critical value, di ba? So, when we type the critical value, we did it this way. First, we type their normal standard inverse of 0.06 divided by 2, which is 3%. And we get this negative 1.88079. So, tama, it's still the same. Then, on the right-hand side, it's this minus 0.03. And you still get the same thing. So therefore, the area where the rejection region happens starts at negative 1.8807. Whereas here, it's 1.88. So tama. So therefore, the rejection region happens when your z is above 1.88 or below negative 1.88. Tama. And that's how we find our critical value. Now, since we've already located where the critical value is, it's time for us to compute for the z-score. You know already what to do, right? So let's compute our z-score. So when I compute my z-score, remember, let's identify the given. Remember what is our sample mean? Our sample mean is 11,960 points. Diba? That is our sample mean. What is our mu? 11,800. What is our standard deviation? 800. And then what is our sample? When he asked 50 randomly selected gamers, that is our sample. So therefore, your formula should look like this. Yan, di ba? So we did it like this. And then we subtract, so we get 160. 800 divided by the square root of 50. This one we rationalize the denominator. Therefore, it's 800 times square root of 50. And then 50 square root of 50 times square root of 50 is just 50. And then ang ginawa ko dito, we cross out 1, 5. Just like that, just like this. This is how I rationalize the denominator. And this becomes 50, diba? And 800 times the square root of 50 divided by 50. The zeros cancel, and then 80 divided by 5 is 16 times the square root of 50. So therefore, your answer looks like this. 160 divided by 16 divided by the square root of 50. Pero we need to simplify. So therefore, 160 divided by 16, and that's 10. So 10 divided by the square root of 50. And we simply need to rationalize the denominator again. So square root of 50 times the square root of 50 again. So that you get 50 on the denominator, and then 10 times the square root of 50. Then 10 and 50, they cancel out. So your 10 cancels out, and 50 becomes 5. So therefore, you have 50, square root of 50 divided by 5, which gives you a z-score of 1.414213. Is that correct? Let's see in Microsoft Excel. So ganito kasi yung ginawa ko. Nag-standardize ako dito. Okay, before that, let's identify the given. So our standard deviation is 800 points. And then our sample, we take the square root of 50, we get 7.071068. Our sample standard deviation is equivalent to 800 divided by 7.07, and we get 113.13 something. And then when we could do our computed z-score, we standardize 11,960 minus 11,800, and then with our standard deviation, sample standardized deviation of 113.13, and did we get 1.14213? Yes, it's a match. 1.14213.562. So therefore, our computed z value is that, and it's a match. Now, decision rule. Where do you think is 1.14213? Dito. But where does it lie? Does it lie within the rejection area or not? Wale. Wale siya sa rejection area. So therefore, what can we say? The null hypothesis is accepted. Ganito kasi yun. So, di ba, remember, tinype ko dito, we type the answer here. Di ba? We type here, if our computed z-score of 1.14 is less than negative 1.88, if it's correct, we reject. Because we only reject the null hypothesis if your computed z value is inside the rejection area, or inside the critical area where we can have to reject. But since it's false, therefore it is accepted. On the right-hand side, remember your p-value is 1.14. If it's outside the rejection area and the positive area, it is accepted. So therefore, that is the correct answer. So ang ginawa ko dito, square root of 50 divided by 5, tama. You still get 1.14214. So therefore, the null hypothesis is accepted, not rejected. Pero dito, sabi dito sa tanong, the conclusion is, he concluded that the null hypothesis was rejected. Is that true? If false, what type of error has he committed? Okay, so ganito kasi yun. In my Stats and Probs book, there are two types of errors that can happen in your hypothesis testing. Ganito kasi yun. The two types of errors comes in handy. Ito kasi yun. Nasa na yun yung... Yeah, I know it's gotta be here. Nope. Yan, ito yun. So, di ba remember, in hypothesis testing, there are 4 possible outcomes in the decision making. If, di ba they said here, the decision is about the null hypothesis. Di ba sabi ko sa'yo, it's either you reject the null hypothesis or you accept the null hypothesis. Whereas, in these are the concepts. If the null hypothesis is true and then you reject it, this is a type 1 error. Ibig sabihin, the null hypothesis, di ba remember, the null hypothesis is correct, and dapat, if that were so, you should accept it. Pero such that you reject it, di ba the null hypothesis is correct, and then you reject it, this is a type 1 error. Pero let's say, for instance, the null hypothesis is then rejected, but you do not reject, but you have just accepted it, yun lang yung type 2 error. So yan, because you have to reject the null hypothesis, if the null hypothesis is false. Yan. So that should be correct. But since you accept your null hypothesis kahit hindi mo siya ni-reject, that is a type 2 error. So those are the two types of errors. So now let's differentiate. What is a type 1 error? A type 1 error happens when your null hypothesis is true, pero you rejected it. Your type 2 error happens when your null hypothesis is meant to be rejected, pero you did not reject. So that is how the type 2 errors are done in your stats and probs. Okay, so now let's go back now to the question. So sabi ko dito, sa stats and probs, the null hypothesis was meant to be accepted. So sabi ni Brother Jason sa game na to, he concluded that the null hypothesis is accepted. Is that true? Pero ganito siya. You see, our null hypothesis does not lie, our computed z-score does not lie on the area where we're going to reject our null hypothesis. So therefore, that is false. So therefore, it is accepted. Diba? And he concluded that it's rejecting the null hypothesis. So, ibig sabihin, the null hypothesis is accepted. Null hypothesis is accepted, pero ang ginawa ni Brother Jason, nag-reject. So therefore, his conclusion is false. Kung false, what type of error has he committed? He committed a type 1 error. So therefore, the answer is wrong. He committed a type 1 error because the null hypothesis is still true even if he did reject it. Just the one I put there in my answer key. Later, I'll show you when we get to the next one. Okay? So now let's go to item number 7. So for the sake of item number 7, it's still the same application for what you've done. This time naman, let's read the problem. Okay? Hayden Haas is a Mario Kart enthusiast. Yaha! It's time for me to play Mario Kart Wii again. Waha! Yeah, I know, pero it's not the time to play Mario Kart Wii right now because we're on a lesson. Hey! Yeah! What's the that? Can't you see where I'm at? I said, yeah! What the fuck, Rafael Lancindo? May lesson pa ako? Ano ba naman yan? Hey! Yes, naman Mario Kart. I love Mario Kart. That's right. Come on. What's the question? Let's read it together. Yeah. And the question is, Hayden is a Mario Kart enthusiast. Furthermore, he even claimed that the time it takes to completing the race differs upon the skills and strategies. To see what he means, he challenged 100 people in Nintendo WFC's VS Race at Moonview Highway Racetrack. Yeah! Yay! Hooray! Did you know that when you play Mario Kart Wii, you can also log on to Nintendo WFC? If you go to Nintendo WFC, you can challenge all your players and all your friends whom you want to challenge in a PS race and in a match, and you can have a good time with all your friends. Let's go! Yup, that's true. Because when you go to Nintendo WFC, you don't just go there to just play with people. You also invite them to challenge them into your game. So yeah, so here's the question. So to see what he means, he challenged 100 people in Nintendo WFC's VS Race at Moonview Highway, and out of the racers whom he challenged, he computed for the average time in executing this course, which turns out to be 137 seconds. Yoshi, 137, that's the seconds, that's 2 minutes and 70 seconds. I think that's too fast to complete the course. Yeah, I know. Yeah, that's only for skilled players. Yeah, I know, that's only for skilled players. Yeah, hey, maybe if I were the fast racer, I can complete it this time. Let's go! Yup, I can say that. But it turns out that his brother, on the other hand, believes in or considers the normal distribution method such that the mean is 140. Diba, remember, sa sampling distribution, the sample mean is our new mean already. Pero kapag normal distribution, the mean of the population is always what we have to consider. Diba? So therefore, yun na yung mga given. The sample mean is 137, the mean is 140, and then the standard deviation is 15 seconds, and yun nga. What is our N? Our N is he challenged 100 people. Diba sabi ko dito, he challenged 100 people in Nintendo WFC's VS Race at Moonview Highway. 100! So therefore, that is the N. Okay? And then our alpha, which is our level of significance, it's 95% confidence level. Okay, so there are two different types of level of significance. When we say level of significance, it uses a small region. Pero the opposite of level of significance, where we have to reject, is what you call the confidence level. Like for instance, di ba remember yung nakita mo, yung naka-white, hindi siya naka-shade, yun yung tinatawag na confidence level. How confident are we to believe that it is still true despite that there's a rejection area to claim that it were false? Like for instance, when I played my Wii, as you can see right over here, I claimed that my Wii is bound to die. But thank the Lord it still works. But thank God through the concept of hypothesis testing, the claim still holds true that I just need to keep my vent like this so that it won't die. Because if I were to turn my Wii backwards just like that, of course, there will be a probabilistic tendency that my Wii will die because there's no air to circulate even up to the back, as you can see there. Alright? So now that is what I mean when we say the alternative hypothesis is meant to be proven. Kaya nga, that is what you call the confidence level. How well do you believe that it is meant to be true? Okay? Like for example, diba? If you look here, diba, remember this is 90%. So we believe that most of everything here is true, while this one, a minority percentage of it tells that it is false. So yun yung ibig sabihin ko dyan. So now, if we use a 95% confidence level, what does that mean? Ibig sabihin, what is our level of significance? Our level of significance is 5%. So 100 minus 95 is 5. And the question is, would you rather conclude that Hayden's brother made a wrong decision? If so, specify the error. So what does that mean? Diba sabi ni Hayden Haas that, Yoshi, when you play Moonview Highway, it takes a mean of 137 seconds to finish the race. That's a sample mean that I got after I challenged 100 people. I want 140. 2 minutes and 20 seconds. That's what Toad said. So his little brother Toad said that he wants it 140 seconds. So which one is correct? Is it Hayden Haas's? Is it the 137 seconds? Yoshi, 2 minutes and 17 seconds is correct. Or the normal distribution, which is 2 minutes and 20 seconds. Get my hypothesis, get me right. Yeah, I know, kids, you're just getting impatient. Just let me focus, okay? Whatever. Anyway, so now let's go to the solution sheet. First, let's identify what our null hypothesis is. What is our null hypothesis? O baka malay mo, you thought kasi the null hypothesis can be seen at the beginning. But this time, it's a trick. Because here it gives you the sample mean. So if you read the grammar, let's read it again. Hayden Haas is a Mario Kart enthusiast. Furthermore, he even claimed that the time it takes to completing the race differs upon the skills and strategies. To see what he... Okay, so we are conducting a two-tailed test because of the claim that says it takes the time it takes to completing the race differs upon the skills and strategies. So therefore, we're using a two-tailed test. Why two-tailed? Because we want to know if it's earlier or later. Yoshi, it might be early, it might be late, depending upon the time. Yeah, it could be early because you're the fastest one to complete. Or it could be late maybe because you got stranded by the items or you got hit by the bomb carts. Oh, no! Yup, that's true. Yay! If the truck were to pass by, here's one thing we should say. Puta ina mo! Tantado, gago, epan, wisit, tantado, inutil, tantado, puta ina mo! Yan, yun yung gusto ko, Rafael Ancindo. Kung gusto mo mangura, yun talaga yung gawin namin. Okay, so back to our problem. Okay? So, di ba remember sabi ko dito, to see what he means, he challenged 100 people in Nintendo WFC's VS Race at Moonview Highway. So, do you know that 100 people there is the square root of N? Tama? And then, out of the racers whom he challenged, he computed that the average time in executing the course turns out to be 137 seconds. So, yun na yung sample mean. Diba? After challenging 100 people, he got a sample mean of 137 seconds. You thought kasi the first mean that you see there is already your null hypothesis. Pero, that is the sample mean. Because the real mean is in the normal distribution, which is 140. So, therefore, ito na yung given. The null hypothesis is the mean is 140 seconds. Whereas, the alternative hypothesis is the mean is not equivalent to 140 seconds. See the difference? So, yan. And now let's identify the given. First, let's look at our alpha. Our alpha is 5%, di ba? 5% divided by 2. And that's 2.25%. 2.5%. And then, di ba remember, 50 minus 2.5, that's 47.5. And we know that 47.5% can easily be found in our Z table. So where do you think is our 47.5% in our Z table? Yan, dito siya. So 1.91, 2, 3, 4, 5, 6. Yan. So negative 1.96 on both sides. Doon siya makikita. Yan. Okay? Yan. So there is where you're gonna find your critical value. Okay? Dito siya, as you can see here. Positive 1.96 and negative 1.96.
What time did I put out your food?
Mga 1.
What time did you eat? 1:30?
Yeah. Okay. So now let's compute for Z. So now we already found our rejection region. Our rejection area is at negative 1.96 and positive 1.96. Now let's compute for the test statistic. Yoshi, let's input the values. The sample mean is 137. Yup, correct. Our X bar is 137. Yeah, the mean is 140. Yeah, I know. And the standard deviation is 15. And we charge 100 people. So therefore, square root of 100 is 10. And 15 divided by 10 is the same as 3 halves. 3 halves is the same as 1 and 1 half. And 1 and 1 half is the same as 1.5. Correct. So just like that. So this is how we divide the fractions, diba? So we got negative 3, and then 15 over 10. We convert that to 3 halves, then we divide the fraction. Negative 3 over 1 divided by 3 halves, or just apply reciprocal to make that negative 3 divided by 3, 1, and that becomes negative 2 over 1. So therefore, it's right here, tama, in our Z table. So we apply the standard deviation, 1.5 seconds, so tama. 137 seconds is in the Z score of negative 2. Yeah! See? I told you, null hypothesis is rejected. I know. Bakit ganito siya? Kasi nga, diba remember, your computed Z score is at negative 2. And negative 2 is inside the rejection boundary. Yoshi. Yeah, and look at that. Do you see your normal curve? This is your Z score, right? Negative 2. And negative 2, your computed Z score of negative 2 lands within the rejection area of negative 1.96. So therefore, it's safe to say that the null hypothesis is rejected. Yay! That's right, Antonio. That is the correct answer. So therefore, it is rejected. So therefore, what is the final answer? Diba remember sabi ko dito, Hayden believed that in the sampling distribution. Compared to his little brother, he believed in the normal distribution. So who is correct? Kasi nga, gusto ni Hayden, this one, he told the little brother, hey, I want the normal distribution. Yeah! Of course. And then this guy, si Hayden, Yoshi, the sampling distribution is more like it. So which among these two do you think will win? Is it Yoshi with the sampling distribution? Or is it Toad with the normal distribution? Take your decision. Yup. So as you can see, we have here, our Z score is negative 2, which lies within the rejection region of negative 1.96. And then sabi dito that Hayden concluded his brother made a wrong decision because his brother wants 140 seconds, and then his brother, Hayden, is 137 seconds. Yan. So using a 95% confidence level, would Hayden conclude that his brother made a wrong decision? His brother did not make a wrong decision. So tama, that's the correct answer. So therefore, if you look at our rejection analysis, dito siya. So therefore, if the Z score of negative 2 is less than negative 1.6, this is rejected. So it's correct. On the right hand side, accept or rejected? Yan, rejected. So therefore, what is our conclusion? Hayden can conclude that his brother made the wrong decision. Because if I remember, his brother said that he likes the normal distribution better. But Hayden said, let's use the sampling distribution. So therefore, the null hypothesis is rejected. So therefore, it's a wrong decision. The null hypothesis, di ba remember, that's a type 2 error. Null hypothesis was meant to be rejected, but they did not even reject it. Kasi nga, sabi ni Yoshi, I want the null hypothesis to be rejected. No! Keep the null hypothesis. I want it that way. Yeah! Yup. The null hypothesis was still accepted, even though it turns out that after computing for the test statistic, it was rejected. So therefore, it is a type 2 error. So yan. That's it. Thank you guys so much, and I hope to see you soon in Moonview Highway. Pew! Ano naman, Kuya Dong, bakit na naman nandito ka? Eh dahil dinalo mo yung mga best friends mo, ano yung gawin namin? Ano? More tawa, masaya! Hey! Tutot! 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 More tawa, masaya! Hey! Tutot! 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 More tawa, masaya! Hey! Pew! Yoshi! Thanks for watching! Yeah! Let's play more Mario Kart! Come back next weekend when we play more! Yeah! Yay! Hooray! Let's challenge ourselves again! Let's go!